Welcome to this video on rounding numbers. After watching this video, you should be able to identify the place value of a number, round to the nearest hundred, ten, whole number, tenth, hundredth, thousandth, 10,000th, and also the nearest percent. You should also be able to identify one common rounding error. Why do we round? Rounding is necessary in many different applications. In math, sometimes calculations result in an irrational number. This means you have an infinite number of digits after the decimal place. Of course, a calculator can't display an infinite number of digits, so an irrational number displayed on your calculator might maybe look something like this. Of course, the number of digits after the decimal place depend on the specific calculator that you're using. So the question that many students have is, if this is my answer, how many of these digits should I copy down? Should I copy all of them or just some of them? And where do I stop? So the easiest way to know what you're supposed to round to is to simply read the directions on the assignment. If you're doing online homework, it will always tell you what to round to. Likewise, on a test, a homework, or quiz, the directions should always indicate what you are supposed to round to if you are supposed to round. So, for example, the directions may say something like round to the nearest tenth or round to the nearest 10. So to interpret these statements, we need to review our place value. Okay? It's also important to notice that tenth and 10, they sound the same. They're actually very different things. So let's take a minute to review place value. So in place value, if I have a number like this, the digit 4 is in the ones place. That means I have 4 ones. The digit 3 is in the tens place, 2 is in the hundreds place, and 1 is in the thousands place. So the way I would interpret this number is 1,234. That's what this part of the number means. Let's look at the digits after the decimal point. The number 5 is in the tenths place. So in other words, this is 5/10. The number 6 is in the hundredths place. So that would be 6 over 100. The number 7 is in the thousandth place. So that's 7 over 1,000. And the 8 is in the 10,000th place. So that would be 8 over 10,000. So let's start with an example. In this case, we're asked to round to the number 12 to the nearest 10. So that means that this number is the only number that's going to stay, potentially, and we're going to get rid of this other digit here, which is the 2. So what are our options? Well, we can either stay with a 1 here, so that would be 10, or we can go up to the next digit, which would be 2, and that would make this 20. So in order to make this decision, we have to look at our number right next to or to the right of the 1. So that number is a 2. So the rule is if this digit to the right of the number we're rounding is a 0, 1, 2, 3, or 4, then this 1 stays a 1. In other words, you would round it to 10. If this digit happened to be a 5, 6, 7, 8, or 9, then we would round the 1 up. It would become a 2, and we would round up to 20. In this case, it's very obvious that the 2, right, the number next to the 1 is a 2, and so therefore, according to this rule, we would round to 10. So we can really understand rounding best if we think about a number line. So here's a number line that goes between 10 and 20. And 12, as you can see, right, is somewhere between 10 and 20. So every time we round a number, we're asking which side is it closer to? So again, my only option, if I'm going to round this to the nearest 10, right, think about counting by tens. You have 0, 10, 20, 30, 40, 50. That's counting by tens. So we have to round this number to either 10 or 20. So all we're doing is we're asking ourselves, which number, 10 or 20, is this closest to? If the 12 is closer to the 10, we'll round to 10. If the 12 is closer to the 20, then we would round to 20. So what we do in order to make these rounding rules is we cut this number line in half. Okay, so if we have a 0, a 1, a 2, a 3, or a 4 after our number, those are on the bottom half. So all of these numbers we say are closer to 10. So they would round to 10. If, however, we have a number that ends in a 5, a 6, a 7, an 8, or a 9, then that means that it's closer to 20, so we would round up. As you can see here, we have this cute little saying, 4 and below, leave it alone, 5 and above, give it a shove. They're similar but different rhymes that you might have learned when you were learning rounding rules. It doesn't really matter as long as you remember them. So again, 4 and below, leave it alone. So the 1 digit here in the tens place would stay a 1. So again, if you had 11, 12, 13, or 14, those would all round to 10. And of course, 10 would stay 10. If we had a 15, a 16, a 17, an 18, or a 19, right, all of these digits, the 5, the 6, the 7, the 8, and the 9, right, they are 5 or above. And so again, we give it a shove, we round them up to 20, because as you can see on the number line, they are closer to 20 than they are to 10. Okay. So let's do some practice here. Let's say I want to round this to the nearest 100. Not hundredths, that's over here, but I want to round it to the nearest 100. So all that's going to stay here is the 1 and the 2. Everything else is going to go away. So I only have two options here. I can either keep this as a 2 or I can bump it up to a 3. Okay, and again, to make this decision, I look at the number that is the next door neighbor of 2. I look at the 7. So if this digit is a 0, a 1, a 2, a 3, or a 4, that 2 stays a 2. If it's a 5, a 6, a 7, an 8, or a 9, it goes up. Okay, so hopefully you can see here that 7, right, is in this second half of numbers. So the number 1274.5678 rounds up to 1300. Again, we make the decision to round the 2 up to a 3 because of this 7. We do not look at any of these other digits. Now let's try rounding to the nearest 10. So here is the tens place. There's a 3 there. So again, for now, we're not going to write any of those other numbers. We're just going to either write 1, 2, 3, 0, right, depending on what the number next to the 3 is, or it's going to become 1, 2, 4, 0. Those are our only two options. Okay, so remember, to make the decision to either stay or go up, we look at 3's right neighbor, which is a 4. So hopefully you can see that the 4 means that we're going to stay. So the number 1234.5678 rounds to 1230. Let's now round to the nearest 1, or the nearest whole number. So remember, that means none of those other digits are going to get written in our final answer. So we either are going to keep this at 1234 or it's going to go up to 1235. Those are the only two possible answers if we're rounding to the nearest whole number. So we look at this neighbor here. Hopefully you can see that this neighbor is a 5, so that means that we're going to round up to 1235. Now let's try rounding to the nearest 10th. Here is our 10th place, so none of those other digits will be written in our final answer. Again, we only have two options. We can either keep it at 1234.5, or we can round up to 1234.6. Again, we look at the next door neighbor. We look at the 6 to make this decision. The 6 is in the second set of numbers, so we would round it to 1234.6. What if we wanted to round to the nearest hundredth, or round to 2 decimal places? So here, I'm going to look at the 6. Okay, so the 6 is going to either stay a 6 or it's going to go up to a 7. Again, those are my only two choices. So I have to look at the number to the right of 6, which is 2. Okay, so the 2 dictates that it stays as a 6. So this number rounds to 1234.56. Now let's try rounding to the nearest thousandth. That's this digit right here. So again, these are our only two options. Okay, we look at the number to the right of 2, which is the digit 1. We can see here that that's going to cause us to stay. So we have 1234.562. What if I asked you to round to the nearest 10,000? Notice to do this, I had to give you more digits to work with. So there are extra place values. Beyond 10,000, we have 100,000s, then millions, 10 millions, and then 100 millions. You don't necessarily need to know all these names. You just need to understand what the question is asking us for. So this might also be described in a problem as rounding to 4 decimal places. So in our problem, that digit is a 1. So that means that we're going to either keep it as a 1 or going to bump it up to a 2. And the way we make the decision to either stay or go up is to look at the next door neighbor, the right-hand neighbor of 1, which is 7. Okay, so we can see that 7 is a higher number, so it's going to make us go up. So this number rounds to 1,234.5622. So another thing that you might see in a homework problem or on a test is asking you to round to the nearest percent. So the first thing you need to do if you have a decimal is you need to convert that decimal to a percent. So for example, let's say you get an answer such as 0.58792. So we first need to rewrite that as a percent, which we do by multiplying by 100%. So that gives us the number 58.792. So now we can round to the nearest percent. Well, what does that mean? That means that this digit is the last digit we write. We're not going to write any other digits. So again, we can either stay at 58 or we could go up to 59. Those are our only two choices. The way we make that decision is by looking at the number to the right of the 8, which in this case happens to be a 7. Therefore, we must round this number up to 59. So again, 0.58792 is equal to 59.792%. And then when we round 58.792%, we have to round it up to 59%. So if you're asked to round a number such as this to the nearest percent, that is how you do that. Let's look at a common rounding error. Rounding a rounded number. Suppose a problem asks you to round this number to the nearest whole number. So that would be this digit right here. In other words, you wouldn't write any of these other digits. So let's suppose that a student first rounds this number to 1,234.5 by using the 8. Then they round 1,234.5 to 1,235. Is this a valid approach or an invalid approach? What do you think? Well, the answer is that this is incorrect. So when you're rounding, you only look at the one neighbor. So for example, in this problem, the number next to the 4 in the ones place is a 4 in the tens place. The 4 tells me to stay. So if I tried to round this way and I rounded it up to 1,235, that would be incorrect. So be careful about trying to round an already rounded number. You cannot do that. You can only round once, and you round based on the number that's just next to it, not two numbers away. So again, rounding a rounded number is not an appropriate strategy.